This is lesson 1-6. We're looking at pairs of angles. So lesson 1-5 was kind of all about angles, angle addition, angle bisector, and now we have some certain pairs. So starting with complementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. So sum means that they're going to add up to 90. And the wording you could see in a problem is that each angle is the complement of each other. Now, one trick I have for remembering that the complementary angles are the ones that add up to 90 is if I draw a line here on the C, the first two letters kind of become that 90. So we have two options for our example. Here, because we have a right angle, I know that those two angles add up to 90. Now, this would be an adjacent pair. And this is a word that we're going to see a couple down in the vocab. The second example, 20 plus 70 is 90. So those would also be complementary, and this would be our non-adjacent example. Supplementary angles are two angles whose measures have a sum of 180 degrees. So again, the sum means they're going to add up to 180. And the wording you could see in a problem is that each angle is the supplement of each other. And the way I have for remembering this is you could draw a line and make an 8 to remind you of 180 with the supplementary. And again, we have two examples. So I know these are supplementary because they make a straight line or a straight angle, which I know in total is 180 degrees. And this would be the adjacent example. And then over here, 115 plus 65 equals 180. So they are supplementary, and this would be my non-adjacent example. So adjacent angles, probably should have started with that, but that's okay. Two angles that share a common vertex and side, but not common interior points. So the word adjacent means next to. So these angles are next to each other. So if we look here, we have angle ABD. And then its adjacent angle right next to it is angle DBC. So angle ABD and angle DBC are adjacent. So they share the common side, which is right there, but they're two different angles that have no common interior points. A linear pair there's a word here. The first four letters spell line. A linear pair must form a line. This is two angles that are adjacent and supplementary. So they have to be next to each other and form that straight line. So here we could say angle 1 and angle 2 are a linear pair. And then the last pair of angles we're going to talk about here, and this is an important pair that we're going to see a lot throughout the entire year, is our vertical angles. These are opposite angles formed by the intersection of two lines. So you have to have two lines crossing. They're opposite. And then a really big fact is that vertical angles are congruent, which means they're the same. They have the same measure. So we have our two lines crossing, okay? This angle and this angle would be opposite angles. And so angle 3 and angle 6 are vertical angles, and then therefore angle 3 has to be congruent to angle 6. So if this was 40 degrees, this would be 40 degrees. And we have one arc mark in each showing that they're congruent. So the other pair of opposite angles here would be 4 and 5. So what I'm going to do is do 2 arc marks, because we already used 1, so we can go to 2. So angle 4 and angle 5 would be vertical angles, and then they have to be congruent. So let's look at some examples. Identify all the linear pairs and all the vertical angles in the diagram. So linear pair was a vocab word, as was vertical angles. So let's start with the linear pairs, and we need 2 angles that form a straight line. So we have a couple lines here. Now, covering stuff up with your hand is very helpful. This would not be a linear pair because there's 3 angles, and a pair by definition is only 2. So let's look at another line. There we go. We have 2 angles that are making up a straight line. So angle 1 and angle 4 would be a pair. And then if we cover that up, we again have a straight line with 2 angles. So angle 4 and angle 5 would be the other pair. The other way is here, but again, it's 3 angles, so not a pair. Vertical angles. Opposite angles formed by the intersection of 2 lines that are congruent. So we only have 2 straight lines here. We have this line and this line. And so because of this, we only actually have 1 pair of vertical angles here. These would be the opposite angles that are congruent. So our vertical angles are angle 1 and angle 5. And we could then say that angle 1 is congruent to angle 5. If this line wasn't here, that would be another pair, but because that angle split up, we don't quite have vertical angles there. Number 2 says, using the diagram, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So let's just talk through this vocabulary. Our complementary has to add to 90. Our supplementary is our 180. And adjacent angles are next to each other. So starting with the complementary, that's going to be our 90. We need 2 angles that add to 90 degrees. So you can just, on your calculator, start adding some of these. And 28 plus 62 is 90. So this we can call angle B because there's only 1 angle there using the vertex. And then this angle, we have 2 angles, so we'll have to use 3 letters. I'm going to call it angle FEG. And those are complementary because 28 plus 62 equals 90. Next, the supplementary pair. So this is our ones that add up to 180. So again, seeing what we can add to 180, and 72 plus 108, and you can check on your calculator if you're unsure, is 180. So this we can just call angle J because it's the only one there, the only angle at that vertex. 108 we could call angle DEG. So that would be our pair, and the reason is because 72 plus 108 equals 180. And then we need our adjacent pair, the pair that's next to each other. So we only have one pair that's adjacent, which is this angle and this angle, because they share the common side. So that would be angle DEG and angle FEG. And ray EG would be the common side. Okay, we have some word problems now. Angle 1 is the complement of angle 2. So I'm going to highlight that. And the measure of angle 1 equals 62 degrees. Find the measure of angle 2. So complement means that these are complementary and have to add up to 90 degrees. So the two angles are angle 1 and angle 2. So we can say the measure of angle 1 plus the measure of angle 2 has to be 90 degrees. And then we know the measure of angle 1. So the measure of angle 1 is 62 degrees. So we can fill that in. So 62 plus the measure of angle 2 is 90 degrees, and then solve. And we get that the measure of angle 2 equals 28 degrees. Let's look at number 2. Angle 3 is the supplement of angle 4. So that means that they're supplementary and are going to have to add up to 180. And the measure of angle 4 equals 47 degrees. Find the measure of angle 3. So our two angles are angle 3 and angle 4. So the measure of angle 3 plus the measure of angle 4 is going to have to add up to 180 degrees. And then we know that the measure of angle 4 is 47. So we can fill that in. So we'll have the measure of angle 3 plus 47 equals 180. And solve. Giving us that the measure of angle 3 equals 133 degrees. Okay, now these get a little bit more challenging, and I'm going to show you one way I think that helps to do these. So it says that find the measure of angle FBD if angle FBD and angle DBE are complementary. So I'm going to highlight and put that I know that that means equals 90. And the measure of angle FBD is twice the measure of angle DBE. So this sentence here is what we're going to need to use. So I know these two angles have to add to 90. Let's start with that. So the measure of angle FBD plus the measure of angle DBE has to equal 90 because they're complementary. Now, this statement is going to tell us what we're going to fill in. And I'm going to tell you that whatever comes at the end is x. So the measure of angle FBD is twice the measure of angle DBE. So the measure of angle DBE is x. And then the measure of angle FBD is twice that. So twice x is 2x. And now we're going to use those to plug in to get an equation. So the measure of angle FBD we said is 2x. And the measure of angle DBE is x. And those equal 90. So 3x equals 90. Divide by 3. And x is 30. Now, remember, we always have to make sure we're finding what is asked for. We were asked to find the measure of angle FBD, which we said was 2x. So then we take our x value and substitute that in. And so the measure of angle FBD is 2 times 30. And the measure of angle FBD would be 60 degrees. Number 4, find the measure of angle A if angle A and angle B are supplementary. So right there, I'm like, okay, I know that they have to equal 180. And the measure of angle A is 5 less than 4 times the measure of angle B. So let's just start with the fact that the angles have to add to 180. So the measure of angle A plus the measure of angle B has to equal 180. Then we're going to look here to get our statements. The measure of angle A is 5 less than 4 times the measure of angle B. So whatever comes at the end is x. So the measure of angle B is x. Now the measure of angle A is 5 less than 4 times that. So 4 times that is 4x. And 5 less than that is minus 5. And now we can plug in. So the measure of angle A, we said is 4x minus 5, plus the measure of angle B is x, equals 180. And we can solve. So 5x minus 5 equals 180. We'll add 5 to both sides and divide by 5. So we should get that x is 37. And then it's important that we always make sure we're answering the question, find the measure of angle A. So the measure of angle A, we said, was 4x minus 5. So we'll take our x value and substitute that in. So we'll have 4 times 37 minus 5 and get that the measure of angle A equals 143 degrees. Okay, let's look at an angle pair problem with a diagram. So find the following angle measures given this diagram and that ray TN bisects angle LTE. So first let's start with our straight lines. So we have a line here and a line here. So that might be helpful. Then let's look at this information. ray TN bisects angle LTE. So angle LTE is here, and that's the angle bisector. Which means now one arc has already been used, so I'm going to use two arcs to show that are the same. Before we even look here, let's just try and find all the missing pieces based on what we know. So right away, I see a pair of vertical angles from our lines crossing. So if this is 110, its vertical angle is also 110. Then I see some linear pairs. So either you see this linear pair or this linear pair. And it doesn't matter, but that will allow us to find this missing angle. So I'm going to look at this one. So we have a straight line. They have to add to 180. So if I take 180 and subtract out the 110, then that angle has to be 70 degrees. Now, if this is 70 degrees, this whole angle is also 70 degrees because like this whole angle and this whole angle technically are vertical, or this and that whole angle have to add to 180. So then this is cut in half or bisected. So if I take the 70 and divide it by 2, each of those angles has to be 35 degrees. Once we have all of that, now let's worry about answering the questions. The measure of angle RTS, we said that would be 70 degrees. The measure of angle STE, we had that vertical, so we said that would be 110 degrees. The measure of angle LTE, so this whole thing we said was 70. The measure of angle E to T to N, 35 degrees. And the measure of angle L to T to N, also 35 degrees. Okay. The last section, and we have I think we have about 7 problems here. Angle pairs with equations. So these are the questions that you need to kind of work through in your head as we do these. And we are going to, for the first few at least, start with writing out the answers. So first you need to ask yourself, what types of angles are these? What angle pair do I have? And then what do I know about these angles? What equation can I write? And then solve the equation and answer the question. So if we look at example 1, determine the value of x in the measure of angle PQS. What types of angles are these? So based on this, we have complementary angles. And then what do we know? We know that they have to add to 90 degrees because this is 90 degrees. Now, you can almost think of this as angle addition too. This plus this has to equal 90. It's just like the angle addition that we were doing. So 3x plus 8x plus 2 equals 90. And then we can solve. So make sure you can solve to x is 8. That's our first answer. It said find the value of x. And then find the measure of angle PQS. So P to Q to S. is there. So measure of angle PQS is 3x. And this is where then we take our x value and substitute it in. So we'll get 3 times 8. And the measure of angle PQS is 24 degrees. Number 2 says determine the value of x. So we have a straight line here that these two angles make up. So most specifically, these would be a linear pair because they're making that line. They are also supplementary. Linear pairs just more specific because they're supplementary and adjacent. So we know, because they make a straight line, that these have to add to 180 degrees. So x plus 20 plus 5x plus 10 equals 180 using the angle addition, the two pieces to the whole thing. 6x plus 30 equals 180 when we combine our like terms, and then we'll solve. And that should solve to x equals 25. Number 3, determine the value of y. So what angle pair do we have here? So we have the two lines crossing, and these are opposite, which means they're vertical angles. Opposite angles formed by the intersection of two lines. And we know vertical angles are congruent. The equal sign with the squiggle. So we put an arc mark in each to show they're the same. So if they're the same, we're going to set them equal. So 4y minus 42 equals 2y. And then we'll solve. You don't want to get rid of 2y because you would have nothing left on that side. So I'm going to subtract 4y. So negative 42 equals negative 2y, and then divide by negative 2, giving me 21 equals y. And this question just asked for the value of y, so we're done. Okay, 4 is our first problem where we have multiple variables. So when we have more than one variable, one way to consider what to solve for is what variable there's more of. So we have 3x plus 7, 5x minus 35, and 3y plus 5. So we have more x's. So we are going to find x first, because there are more x's. And so then I'm going to set up kind of those, I don't have the lines here, but we're going to think through the same questions. So for x, question 1, what types of angles or angle pair do I have? So we have lines intersecting, and these are where the x's are. So those are the opposite angles. So we have vertical angles. And so we know then that they're congruent, one arc in each. So 3x plus 7 has to equal 5x minus 35. And then we can solve that. So 42 equals 2x, and then I'm going to divide by 2. So our first answer is x is 21. Now, not always, but often what you're going to have to do if you have multiple variables is substitute x in and find something. So for example, this angle is 3 times x plus 7. But I now know x is 21. So this would be 3 times 21 plus 7. And that comes out to 70 degrees. This would then also be 70 degrees. And now we're going to use that to help us find y. So one thing we can do in class, right? I've been using my hand, but you can also sometimes use sticky notes to make the problem seem smaller. So now if I look at this problem and forget about the x because I know it's 70, I have two angles that make up a straight line. So now I have a linear pair. So I know that these have to add up to 180 degrees. So 70 plus 3y plus 5 equals 180. Combining my like terms and solving. And we get our second answer that y is 35. Okay, question 5. Determine the values of x and y. Now, we have two expressions with y and two expressions with x. So it actually doesn't matter which one we find first here. And unlike here, we had to find x, substitute it in to be able to find y. These are kind of separate problems. So let's look at our x's, again using that sticky note. If I cover this up, I have two angles that make a straight line. So I have a linear pair, and these have to add up to 180 degrees. So 3x plus 5 plus x plus 15 equals 180. Combining the like terms, we get 4x plus 20 equals 180, and solve. And we get our first answer that x is 40. Okay, then if we look at where the y's are, now we're covering up this half of the problem. Well, I have two angles that make a straight line. So I again have a linear pair, and these are going to have to add up to 180 degrees. So y plus 20 plus 4y minus 15 equals 180. Combining our like terms, we get 5y plus 5 equals 180. And that solves to y equals 35. Okay, if we look at number 6, determine the values of x and y. X, X, Y. So there are more x's, so we are probably going to have to find x first. But there's a lot going on here. What stands out to me, and I'm going to highlight these 2 lines. And I'm not going to use both x's to start. So those 2 lines intersecting, those are opposite angles. So for the x, just the 7x, so again, not all the x's, and the 56 are vertical angles. So we get 7x has to equal 56. And when we solve, we get x is 8. We can then substitute that back in now for multiple spots here. So this would be 7 times 8, and this angle would be 56 degrees. And this angle would be 2x, 2 times 8, 16 degrees. Now when I go to look for y, I realize, now I'm not going to call it a linear pair because I have a straight line, but I have 3 angles, 1, 2, and 3. So we have a straight line. A linear pair implies only 2. But it's a straight line, so it's a straight angle, and I still have to get to 180 degrees. So the first angle, 56, plus 16, plus y has to equal 180. Combine your like terms and solve. And y is 108. Number 7 is one we're not going to do. This would result in a system of equations, which is something you did in intermediate algebra. And so that would be like a really hard challenge problem, but we are not requiring that you would know how to do that. So then the 1-6 homework is what goes with this lesson.